2.1 will start here. 2.1, we're going to be interpreting these things called relations and these things called functions. Functions you've probably heard of, relations, yeah, maybe not. The correlation between relations and functions is kind of like the relationship between a square and a rectangle. You know how you've got rectangles, and then a square is a certain type of rectangle, right? So every square is a rectangle, but not every rectangle is a square, right? So by the same token, we're going to be, a relationship is the big picture, and all it means is that you're pairing numbers together. We'll talk about that. Oh, it's not a relationship. Look at me. Relations. Hello. And then in relations, a certain particular type of relation is called a function, and we'll talk about that. So every function is a relation, but not every relation is a function. Okay? So give you kind of a place to put in your file. So here's the things we're going to talk about. Hopefully some of these will start spurring some memories in your head. We're going to talk about input versus output, relations versus functions. I've already said that. We're going to talk about the various representations of functions and relations. We're going to talk about discrete and continuous, and we're going to talk about domain and range. Hopefully a few of those. Some of you never heard of probably, but others you're like, we spent a lot of time on that. So here we go. Let's start with the word function. Functions can sometimes scare kids to death because it makes it sound like it's so hard. But in reality, and you don't need to write this down, guys. Just listen to me, okay? The only thing a function is just a job. If I say, what is the function of the police force? What do you tell me? Keep us safe, law and order. What's the function of a school? To teach kids, okay? That's their job. It's their function. So a function is simply that. It's just a job. It just so happens what you're doing, okay, educators keep kids educated. Policemen keep people safe. Numbers tell numbers what to do. Functions tell numbers what to do, okay? But it's still just a job. It's just a job. So for example, let's look at this. This is a box, right? This is a factory, okay? It's a function. And the function or the purpose of this function, this job, is to take things, put it in it, a number, put it in, and go, I'll put it in 2. 2 plus 3, spit out a 5. Its job is to take whatever I put in it and add a 3. Now we write that as a function, and it makes it look scary, but all it's saying is the function of this machine is to take whatever you give it, add 3. It's very simple. You have an input, you have an output. So let's talk about this input and output. What you put in has several names. The first one is input. Can you, just from what you know of the past, what other things can you call this thing that comes in? Any ideas? Let me ask you this. Do you put the X in or do you put the Y in? You put the X in. So it's your X's. Your X's are your inputs. Let's see, what could this be? Remember those two words, domain and range? Mm-hmm. Which one's your X's? Which one's your input? Remember? Domain. Yep. Domain and X's. And then the other thing down here that you probably won't think about is that the X is your independent variable. It's your independent variable. What I put in there causes this to happen. This thing doesn't cause that to happen. So this is independent, this is dependent on whatever I put in. So X is my independent variable. So let's do similar things to the output. So if X is the input, this is the input, what's that going to be down here? Output, yes. If the domain is what you put in, what do you put out? The range. The range. With a line in it. Instead of X's, what comes out?
Y.
Your Y's come out. Gosh, why are you doing that? Come on, 3 times the charm. Make it 9. And then, as I said before, the independent variable comes out, it goes in, and then out comes the dependent. It's very dependent. As it changes. Every time that x changes, the y changes too. Okay? And one other thing about this little machine is, okay, take this 2 that we put in right here and this 5 that came out. That actually you can turn into an ordered pair, 2, 5. Remember, 2 is your x, 5 is your y. And that will actually be a point on this graph. If you graph this thing, this is a line, right? Isn't it supposed to be? If you graph that, that'll be one of the points on the line. Big puzzle, you put it all together. It's pretty fun. I love math. Yes. Yes, yes, that's what, because, yes, this means the function of putting x in. But what comes out is your y. So yes, that's why your teachers have been telling you, just mark that out because what you get is a y. And you can, but we need now in Algebra 2 to start understanding what is the f of x. It simply means it's the function when we put x in. Okay? All right. So let's talk a minute about relation. Relation. A relation is simply a pairing of two things. Get out your phones real quick. We'll do something with your phones. Okay, back in the olden days when we had flip phones like this, and we wanted to text, we didn't have a keyboard to text from. Instead, I don't know if you've even noticed, but look at your number 2 on your phone. Do you see the letters around it? It can represent an A, B, or a C. And then 3 is what, C, D, F, or C, D, D, E, F, so on and so forth. That's a universal language right there. The 1 has nothing under it. Don't know why. I don't know why they wouldn't start a 1 with ABC, but it doesn't matter. They didn't ask me when they invented this. So, way long time ago, if I wanted to type hello to you, to text you, I would have to find the H on my phone. And where is H? 4. It's number 4. But is it the first letter number 4? No. Okay. Oh, it's not. What is it? It's the second letter. So I would have to punch 4 twice, real quick. 4, 4. And that'd give me an H. And I'd be so proud. And then I needed to punch an E. Where's the E? It's the number 3. How many times would I have to push it? Twice. Very carefully. 3, 3. You'd have to do it fast enough, but you'd have to pause enough between these two, or you get an error. So it's very timing was very crucial.
Well, sometimes we start guessing, but you have to say, so we just get back to that.
Oh, it didn't then. Oh, no, we had no text, what do you call that? Autofill or predictor. No, are you kidding me? That is a very smart technical thing. All right, then I had to type 2 L's in a row. This one really got you. An L, how many, what do I need there? 3 5s. So I have to do fast enough to go 5, 5, 5. Wait a little bit. 5, 5, 5. And then finally I would get to, oh, what would I do there? Put a 0. I think, no, it wouldn't do, because a 0, what would a 0 give you? Other letters under a 0? Is there anything? Here's a plus sign, they give you a plus. You couldn't beat it! So what am I going to do for an O?
6 3 times.
6 3 times? 1, 2, 3. So, bottom line was, I would do all of that, and all I would accomplish was, hello. You see why we didn't text for a long time? But then once they put the keyboard in, it was, like revolutionary. It was like, type all day. So, texting has come a long way. Now, this is an example of a relation. Because what happened is, the 1 is connected, no, the 1's not connected to anything. The 2 is connected to A, B, and C, right? The 3 is connected to D, E, and F. I could turn each of these into ordered pairs. I could say this is 2A, this is 2B, and then 2C, and then with 3's, 3, oops, we need to do that. 3D, 3D, 3E, comma, those are like ordered pairs. What would be the domain of this relation that's going on here? Which are what? 2 and 3. So the domain, if I just stuck with number 2 and 3, my domain would be 2 and 3. And usually you put them in set notation, but kids have a hard time with set notations. What would be my range? Okay, A, B, C, D, E, F, right? So you don't just think of domain and range as being, it's not always numbers. It's a pairing of anything. Anytime you pair stuff, you're forming a relation. All right, so relations. A relation is a pairing of an input to an output. And they can be shown as ordered pairs, which I showed you. They can be shown in a mapping diagram, which was what I showed you. This is actually the way to do a mapping diagram officially. They put a little rectangle thing to draw arrows. That's called a mapping diagram. You can also find relations expressed in equations, which I'll show you some in a minute. And you can also find them expressed in graphs, which I'll show you in a minute. So, this whole thing going on here with the phone back then, that was a relation, it was not a function. Well, how do I know that? Well, let's talk about what a function is and then you'll understand. I'm going to give you some, don't try to write all this down, just write the shorthand here, okay? Okay, so a function is a special type of relation. We've already talked to you about that. It's a subset of a relation where there's only one output for every input. All that means is your domain never repeats. Your domain never repeats. In other words, you won't have 2 x's that are the same. Well, right there, that cinches it right there why this thing's not a function. Because when I listed them out, 2a, 2b, 2c, look, my domain repeated 3 times. So that's why that was not a function. It's still a relation, it's still a pairing, but it's not one of those spatial ones. It's not a function. Okay? All right, and here's the 3 main rules. Let's assume that A is the domain, B is the range. So we're talking about this kind of an ordered pair. So here's the deal. Each element in A must be matched to an element in B, which means no domains can be left out. No domain left out. Every one of your x's, every one of your inputs have to have a partner. You can't have one that's alone without a pair, without a partner. However, look at the second one. But some elements of B may not be matched to an element in B. So that tells you that some of the ranges can be left out. Range members can be left out. They can be unmatched, or how you want to say it. You don't have to have a partner. All of your X's have to have partners. All your Y's do not have to have partners. And then the last one, one element of A must not be matched with more than one element of B. In other words, your domain can only have one partner. Your X cannot have more than one partner. X cannot have more than one partner. So keeping those rules sitting out in front of you, I'm going to show you a bunch of different types, and you're going to tell me if it's a function or not. Don't try to write these down. You don't have time to learn more just by participating with me here, okay? I think that's all I have on there. Yep. All right, so here we go. Look at this first one. Is that a function?
Yes.
Yes. It's okay that these left out, because remember, the range can have a leftover. So yes, that is a function. How about the second one here? No, it's not. Because 4 needs a partner, right? Your X's have to have partners. That is not. Here we go again. Yep, not a function. This guy here. No, for several reasons. The main one being, one has two partners. And two only has one partner. Three only has one partner. But one has two, so this is a problem. So no, that's not. The next one. Same reason, right? One has two partners and two has two partners. And that's really two-term. No, for sure. Okay, what if you see a list of ordered pairs and you want to know if it's a function or not? Well, let's look at all the x's. Are any of the x's repeated? So yes, it's a function. Woo! You got a little carried away there. Come on. Okay. How about the second one? Not a function, is it? Because at -8, he's got three different partners. Do this, shame on you. So, no, it's not a function. There's a no under there. Okay. How about the last one?
Yeah.
Does it matter that this has a bunch of repeats?
No.
Nope. The y can repeat all day long. Good, excellent.
Yeah.
Okay, how about if it's in chart form? Look at this first chart. Because I don't have any repetition here at all. So yes, that's a function. It's just not letting me do it anymore. How about the next one? No. Yes, so. Because the 10's a two-timer, and so is the 7. Good guess. Nope. All right. Good. What if I give you a graph and ask you if it's a function or not? Okay, just got to think about this a little harder. So these are some goofy looking graphs. Mostly what you're familiar with from Algebra 1B is linear. You know how to graph a line, hopefully. We're going to do more of that, review that tomorrow. But these are some more advanced graphs, which we'll get to later. So this was a bunch of points that we added, that we decided to put all together, and it formed this looking guy right here. So I want to know, is that relation a function? Woo! How did y'all know already?
There's a line in the x-axis.
Remember the vertical line test? The vertical line test says that if you draw a vertical line, you can only hit the function one time. So if I draw a vertical line right here, it's only going to hit the function once. Here, it's only going to hit it once. Here, only going to hit it once. And that's going to happen no matter where I put a vertical line, it's only going to hit the fit function once. So that does pass the vertical line test. So yes. Whoa! Wow. Oh.
Just get behind you.
Oh, good idea. Undo how many times? 3?
Yeah.
All right. Woo. Okay. So we said yes, it's a function, right? Down, go. Then why didn't that work? Okay, there's a no there. I mean, there's a yes there. That is a function. Yes, there is a function. Oh, oh no, I don't know what's happening. Okay, let's look at this parabola here. Is that a function?
Yes.
Because no matter what vertical line you draw, it's only going to hit the function once. So yes, that is. How about this little freaky guy?
No.
No. Now, so if I draw a vertical line, let's say I draw a vertical line right here. I'm just going to hit it twice. Well, look at what this point is. This is the point 1, 2, 3, 4, 5, 4. And this is the point 5, -4. Oh, look what repeats. See that if you have a vertical line test, if it fails the vertical line test, that means that X has two partners. Bad. Okay? So that is not a function because it fails the vertical line test. Okay, we doing all right? Okay. Now let's talk about this whole discrete continuous neither thing. Okay? Don't write a bunch down yet. Let me give you a scenario. You all know that you have certain friends that if you tell them a secret, you can trust them. And sometimes you'll tell them, you know, I'm going to tell you a secret, but my mom's the only other person that knows. And then they talk to your mom after you tell them that or whatever. But they're very good about keeping your secrets and keeping it just between a few people. Then there's other people you know. that if they get wind of anything, they just blah, 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 blah to whoever listens. Whoever, whatever time, they don't care, they'll tell the dog. Okay? They just continue to blab. All right. I want you to keep that little story in mind when we think about if a relation is discrete or if it's continuous. A discrete function is just what it says. It's just a few individual dots. You just told your secret to a few people and it just stayed within the few people. I did not draw a line and spread the rumor to everybody that I passed on the way to the next line. Just kept it very secret. So if you just see some dots on a page, that means this would be a function because you could still try the vertical line test on it, but it's a discrete one. It's a discrete function. This right here, you told a secret and she just started blabbing. The second she walked out, blah, 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 till she got home. You never picked your pencil up. A continuous function, you connect all the points and you never lift your pencil. Blah, 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 blah. Okay, so they're really pretty easy to recognize. Then there's some that are kind of neither. Because this little guy, this is called a step function, which we will learn about later. You know, they blabbed for a little while, but then they stopped. But then you have to pick up your pencil. Then they blabbed a little while, and then they stopped. Pick up your pencil. Blabbed, and then blabbed a little while, and then stopped. So that's not, it's kind of, you can't, we don't call it both. We just say it's neither. Because it breaks the rules of both of them. So that's neither continuous or discrete. All right, so again, I'm going to give you some functions or some pictures, and you're going to tell me if they're continuous or discrete. Again, don't try to write them all down. Just give you a few key words to remember what discrete is. Oh, but before we do, let's talk about domain range real quick. What about it? Oh, yeah. This is just a review. So domain is the set of input values. They're the independent, right? Range is what comes out. It's the output values. It's the dependent variable. And let's do one, I've got a chart here. What would the domain be of this chart? The years. So it'd be 1900, 1920, 1940. So see, in this case, the domain is years. That's weird, but no, it's not, because you're just pairing two things. You're pairing dates with the amount, the rate of a stamp. What's a stamp now, first class? Isn't it like 48 or something? I feel like it's almost 50 cents.
A stamp?
First class stamp.
Oh, beats me. I haven't bought a stamp.
I know, y'all don't. Y'all just electronic everybody, but I think it's close to 50 cents. Yeah, email. Even Christmas cards now. People are doing email Christmas cards. Forget the stamp. Forget the picture. We'll send you a picture online.
It's free.
It's free, exactly. Then what would my range be here? What would my range be? 2. You do not need to list the 2 twice. So what's next?
3, 4, 15.
That's a 15.
Yeah.
Okay? Are you okay with that? All right. Now, I'm going to give you a chart or a picture. You're going to tell me if it's discrete, if continuous, or neither. We're going to talk about what the domain is, what the range is, and is it a function. So we've just learned together. You're not going to try to write these down. You're going to ask me questions if you don't get it. And we're going to look through these real fast.
Okay.
All right, let's first look at it. The easiest to tell, is it discrete or continuous? Discrete, for sure, because it's just little dots here and there. Okay? All right, now the domain. What are the x's?
Wow.
Well, this point right here is -3, -4. This point is, thank you,
1, 3.
1, -2. All right, so what is my domain?
Negative 1.
Okay, my range?
5, 3, 0, -2.
Okay, nothing hard there. Is it a function?
No.
No, good. Because if I put a vertical line right here, then it's going to, the one has a partner of 3, has a partner of -2 as well. No. Wouldn't be pretty. Okay, let's look at this one. Think about it a minute.
That was very confusing.
Continuous or discrete? Continuous. You never have to stick up your pencil.
No,
Now,
not a function.
okay, well, let's do not a function. That's pretty easy, right, to tell. With any vertical line test, it's going to hit it twice. Okay, but now let's talk about domain and range. The first time I'm going to show you this, I'm going to be very specific and probably give you more information than you need. But then after that, we'll get the big picture. Okay, this point right here is the point 2, 1, and then we have 2, 2, and then this is, that's not 2, 2. That's 1, 2. 1, 2. This one is a 0, 2, 3. And then we have -1, 2. Am I doing okay? -2, 1. And this one is -1, 2, 3. There we go. -3, 0, and this is 3, 0, and I can go on and on. That's enough to talk about. Okay, so what is my domain? What are my x's? -3, -2, -1, 0, 1, 2, 3, and everything in between. Because right here I have -2.5, 1.5, or a half, and a 4. And so it's every dot in between there too. That's what the line means. That's why it's connected. So it's really going to be every number and every fraction between a -3, and we're going to use interval notation, between -3 and +3. Okay? Now let's look at the range. So now I want my y values. My y values. This is my lowest y right here, and this is what, 0, -4? So that's my lowest value. I've got something at -3 here, something -3. I've got something -2, -1, blah, blah, blah. Same over here. So 4 is going to go from -4, -3, -2, -1, 0, 1, 2, and 3. So it's going to go from -4 to 3. Okay, and here's something to note. Well, you don't need to do it. I'm going to show you an easy way in a minute. So basically what we're asking on a continuous function right there, when you're looking for domain, you're wanting to know what's the furthest left it goes, what's the furthest right it goes. In this case, the furthest left it ever goes is to -3. The furthest right it ever goes is 3. With range, you want to know how high does it go and how low does it go. But we always read a graph from down up. Okay, don't read from up down. From down up. So the lowest, we're going to go with the lowest is -4. The highest is 3. So just look for the extremes. You don't have to write all those dots. I'm just showing you. Yes. Yes. Okay. Now we think we have it. Continuous or continuous. Once you start, you never pick up your pencil till you end. Continuous. As a function. Yes. All right. What's the furthest x I'll ever have to the left? -4. But there's an open circle there. So I need to put a parenthesis here instead of a bracket. Y'all okay? Okay. What's the furthest right this thing will ever go?
Forever.
Infinity. Because of this guy right here. He's going to keep going to the right forever, never, never. So infinity. Hey, what's the lowest this guy will ever go? 1. What's the highest he'll ever go? Infinity. See, it's not that hard. So just think extremes.
What would cause a point to not be filled in?
If it's representing a fraction, and this bottom was an x plus 5. Let's say we have this that we're graphing. If I put a -5 in for x, it would cause my denominator to be 0. So I cannot. So I can't use a -5. So I have to put an open circle. We'll get to all that later, but that's what that is. Okay. Circle here. Is it a function? No. Continuous or discrete? Yes. Furthest left. -2 including, all right? Furthest right. Furthest down. Furthest up. Not hard. Y'all are good. All right. Continuous or discrete? Function.
Yes.
Big Y. Domain. Furthest left. Okay, and then we'll put -infinity to infinity, right? And range, furthest down. -infinity, highest. Oh, should the brackets what? No. Not with infinity. We never, who asked that? We never reach infinity. So we'll always put parentheses around. Okay. Continuous or discrete? Beautiful. Function.
Yes.
Yes.
Trick question. Furthest left. -infinity. Furthest right. Okay, the range, the lowest. Inclusives, highest. Oh, good. Not a function. Continuous.
Yes.
Furthest left.
0.
Right. Oh, too good. Left. -infinity. I mean, I shouldn't have said left. I should have down. Down, -infinity, up.
So why is it not a function?
Because a vertical line test would hit it
Oh, yeah.
two places. All right. Now, I'm gonna give you 60 seconds, and here's what I want you to do. I want you to take, first I'm gonna pause this.
Oh, I have a question.
2.2. Okay, so slopes. You have been doing slopes all your life. Not all your life, that's certainly an exaggeration. But you've seen slopes all your life. Slopes on roofs, slopes on wheelchair, handicap ramps. Slopes are everywhere. You see them all the time. They're really important. Another thing you call them as you get higher in your math classes, we don't call them slopes because that's a baby word. We call them rates of change. How often, what is the rate at which they go up? Do they go up fast or do they go up slow? Those are called rates of change. Okay, so don't let that word scare you. Yeah. We need slopes. Okay. Tell me what formulas you remember. There we go, about slopes. Y was an X plus B. What else do you remember? I think this is what you meant. Okay, give me another one. Which is?
Oh, it's
Y minus Y so Y equals M.
X
minus
X minus X.
Okay, give me another one.
AX plus BY equals.
Yeah, good. AX plus BY equals C. What's that? The standard form. Very good. The standard form. How about, that's good enough. No, these other forms. Y-intercept, Y-intercept, point slope, and standard. That's the three forms. Good. And this is when you're given two points. Points. Okay. All right, a vertical line looks like this, right? What kind of slope is that? It's undefined, it's non-zero. It is undefined. Some books say there is no slope. And you can call it either one of those is perfectly fine, either undefined or no slope. Because here's the deal: if you are skiing, and you came to this black diamond and you went you would be no more. There is no slope. You're going straight down. You have no life. Okay, you would be dead. On the other hand, if you were on a bunny slope that is vastly horizontal, how fast would you be going? 0 miles per hour. This slope is 0. Because when you stand on a flat ground, you don't go anywhere and just push yourself. Have a little thrust, whatever that is.
What about the
What about the what? Oh, you make life too hard. Positive slope, does it lean to the right or to the left? Right, it leans to the right. Negative?
Leans to the other way around.
The other,
Downright.
yeah. Okay, remember all that, all right? So don't be scared of word problems, guys. A skateboard ramp has a rise of 15, and a run of 54. Rise over run, remember that? And rise over run, that's why we put the Y's on the top when you're subtracting the points, because Y's rhymes with rise.
Oh.
Yes, because you always remember rise over run, but sometimes you forget. X's on top with a Y's with rise and Y's, rhyme, same spot. Okay? So, my rise is 15, my run is 54, just reduce that a tad. 3 goes into both of those. 5 over 18. So the slope would be 5/18. So don't freak out on the word problem, there's nothing to do, just find the rise and the run. Rise is this way. Run is this way. You don't run this way. You run this way. You rise. Okay. So here's where we have 2 points. It's going to go through the point -1, 3, and 2, -1. What is the slope? -1 minus 3 over, and this is the only thing that gets kids. This is 2 minus -1.
Oh, so it must be a plus.
2 minus -1. So watch that double negative. That's the only thing that can get you. -4 over 2. So this is a negative slope. -2 to be exact. Now, if I wanted to check that just to be sure, I would
No,
go.
that's-
I know you wouldn't. What?
That's
Because
exact,
that's
that
not
should
yours.
be -4 over 3.
Over 3, like I
Yeah.
said. -4 over 3. You just misunderstood me. Right.
A.
So that would be A.
That's not even an answer for it either.
What?
It's
Like
an
a
S.
child. No, her original.
Oh, of course not. Okay, so, if I were to graph these two, -1, 1, 2, 3 would be here, and 2, -1 would be here. And if I drew a line between them, then I could rise 1, 2, 3, 4, and go to the left. 1, 2, 3, that's 4, -3. Bingo, got it right. Oh, does it matter? This, is that the same as this?
Yes.
Is that the same as
No.
this?
No.
Yes, yes, yes. Those are all the same. It's just a negative, because from here, I could also go, or from here, I could go down 4 and to the right 3, down 4 and right 3, or I could go here and go up 4 to the left 3. It doesn't matter. You have one negative sign, it's a -4/3. Doesn't matter where that negative is.
Plus.
All right, let's say we got a sequoia tree. In 1965, its diameter was 137 inches. You're one of those tree people that likes to study trees. In 2005, you measured it again, and it was 140 winches, 141 winches long. And we want to know what's its rate of change? How much is it growing each year? So we're going to turn those into ordered pairs. Okay? These are our X's, these are our Y's. So 1965, 2005. And the other one is 137, 141. And we're going to subtract. 141 minus 2005 is, help me out. Wait, what did I do wrong?
I don't know.
You paired up the X's.
I did. Whoa. 1965 was 2005.
No.
1965.
Was 1/3.
137.
Good thing it's 4 o'clock. 1965 is 137 inches. 2005 is 141 inches. There we go. All right. 141 minus 137. 2005 minus 1965. We get
4.
4 over
puppy is growing 1/10 of an inch or a centimeter, inch, okay, inch per year. That is one slow growing gene. That's its rate of change, that's its slope. Okay. We got this railway car, whoop, it's in Pennsylvania. Anybody been on the Dick Green incline? Remember that word is? Don't freak out, it's a word problem. Oh no, it rises 400 feet over a horizontal distance. Over a horizontal distance. Horizontal. You look this way at the horizon. You don't look this way at the horizon. Horizontal distance. Oh, that's a run. So it has a run of 685. So what's the slope of the incline? Rise over run. Let's divide by some things. 5 we're going to go to those. Is that about it? Yeah, I think that's about it. 127 is what I remember. I don't think you have any difference. Okay, so we got that. Woo! Oh,
Yay!
you're so awesome.
Yay! We did it, guys!
All right, back for her.
But you know, that's okay.